It's tough. Okay, you're given a problem. You've got all these different rules that you've got to keep in mind and use correctly, and somehow use any combination of those rules for any particular problem that you're given. I don't have a cookie cutter approach to you. I don't have center shape spread outliers. Write those words. And then randomization replication. I don't have any this is how you do it little tricks to do probability problems. In general, what I would ask you to do is to try to read the problem and see if you can change those words to these symbols. Okay? Then, we have a couple of diagrams that might help us. Perhaps a Venn, perhaps a tree, or maybe not. Okay? In general, I think if you're doing a problem using the OR, a general addition rule, I think a Venn might work pretty good for you in those problems. If you're doing some sort of multiplication rule, finding the intersection of things, I would maybe try a tree first. Okay? Or it's possible that, no type of picture is really going to help you that much, but I've given you information in the problem and you can stick it directly into these formulas and just figure it out that way. So probability is a series of hit and miss. Try something. You might go down the wrong road. Go back to the beginning, try something else. Okay, but there's a brute force aspect to probability that you got to go with. All right, here's what I've given you now. I'm trying to figure out the chances someone's going to be a pro athlete. Okay, that's ultimately what I'm looking for. And I've given you some hints. About 5% of people going to college actually play sports. 1.7 of those college athletes actually go pro, and then 0.01% of the non-college athletes end up going pro. That's enough information for you to be able to answer the question that I'm being asked. So let's go through the first step. Let's try to change those words into some sort of symbols. Now make sure we have our symbols. We can just look at it and kind of make sense of what's happening. So how about the first one? What do you want to do? How do you want to change this one to symbols?
Could you put probability of C, like going to college, equals 0.05?
Yeah, I like that. I had a lot of people today put probability of H, meaning high school. Well, no, everyone goes to high school. I had some people say college given high school, but you've got 100% of the people going to high school. So this isn't one of those conditional probabilities. You just start from when they're leaving high school and go on to college. I like this one the best. Probability that you're going to play athletics in college is 5%. Keep going. You're on a roll. What would you go for the next one?
I would put P given college.
Yeah, I agree. Now notice in this one I didn't make a big given they went to. Okay, it's just kind of written up, but I agree. These people that have gone to college, this is the percent that actually went pro after that. I like that very much. 0.0 is a 1/7. And how'd you do the last one?
I put P and C.
Okay. So the probability of going pro, given they did not go to college. Now what you write here?
0.0001.
Okay. Get comfortable with these decimals, okay? I saw a couple of mistakes going around looking at the homeworks last night. This is actually, move that decimal over a couple of places. If we're going to write them in decimals, that is correct. So that's a great start. Okay, now, big deal. What are we looking for? What are we ultimately, if I had to put into symbols what we're looking for, what would you say?
P.
Yeah, what's just the probability of going pro? Now, unfortunately, I don't have a formula over here like that. I mean, I guess I do here, right? The probability of an event happening and its number of occurrences, but that's not the information that we've been given. So, at this point, if I got a bunch of information and I'm looking for that, okay, I can just plug them in and go. I don't even have to draw a picture or anything. But I don't have that right now. Okay, now I do know that these guys, we talked about this yesterday, remember that's down your tree. Something else happened first, and these are down your tree a little bit. So I saw a lot of you kind of moving towards trees, slowly but going there. Okay, to see if that might help us to see what's going on. So let's just keep going here. What would a tree diagram look like in this particular problem?
Well, I put like high school as the starting point.
Yeah, I used high schooler there, sure.
And then I put 0.05 and have that branch to PC.
Okay, no, sorry, C, right?
Yeah, PC.
All right, so chances of going on playing college athletics, 5%. Now, complete the tree. I saw a lot of you keep going there, but I can do more here. Can I do this? And what would that be? What?
0.95.
And how'd you get that?
Because there's 100% of high school athletes, and it's only 5% of them go to college, and the other 95% don't.
Right, we're using rule number 4, right? Complement rule. Okay. All right, so that takes us right there. But then, what do you got here?
I got 2 branches. One goes to pro, one goes to not pro.
Okay.
The one that goes to pro goes 0.017, and then the bottom one goes 0.983.
And remember, this is already, college has happened. We're working our way down the tree. Now, what's the chances of playing pro once college athletics have already happened? I like that. We can do the same thing down here, probably going pro when you're not going to college. That's what this one is. So these were going down your tree. What is this, 0.9999? Not going pro. Now again, we might get to this point and say, oh, that doesn't help us either. In this particular problem, it does. Okay, but I think a diagram kind of helps us here. Now, from this diagram, can I figure out how a person can become pro? What'd you do?
I took, since there are 2 paths to becoming pro.
Yes, there are 2 paths to becoming pro. There's 2 different ways you can become a pro. All right, now let's talk about this. We're going to multiply our way down here. So what is this? It's the probability of, starting from the beginning.
P given C.
No, it's not. P given C. It's just that. What is it starting here, going all the way down here? What are we doing?
Oh, it's P and C.
Yes, this is the probability of turning pro and going to college. If I was to use my formulas here, that's the probability of college times the probability of pro given college. Plugging in my numbers here, I've got 0.05 times 0.017. And what did that come out to? Somebody got that? Anybody?
8.5 times 10 to the negative 4.
Okay, so you give me the decimal for that. Is that 3 zeros?
Yeah.
And then 8. Okay. All right, and he already said there is another way. But answer this question for me. The person can do it by going to college first. What's the next word? Or. We'll talk about that in a second. We can do it by not going to college first. If I was to write out what we've got here, it's the probability of not college and turning pro, which is the probability of not playing in college, times the probability of going pro given you didn't play in college. So I've got 0.95 times, you got all your zeros and ones. And what did that thing come out to? How many zeros?
4.
And a 95? So in this particular problem, we've now used the multiplication rule, the general multiplication rule. Now what are we going to do with these 2 numbers? You're going to add them. Now, or is addition rule. Let's go to the general addition rule. Okay, it says we can add them, but then we have to subtract any overlap. Is there any overlap in here? In other words, can I go to pros by going to college and not going to college at the same time? No, so these are mutually exclusive events. So yeah, we can just add those 2 together. And when we add those 2 together, what's our final result? 0.00945. So we actually used all 3 steps in this particular problem. Okay? Try to write down what they've got. This is tricky. This is a hard step to be able to decipher the sentence and figure out what we've got. Write down what we're looking for. And then being able to, in this case, use a tree diagram to find out all the ways. fortunately, you've only got one more formula you have to learn for this particular chapter. I want to take a look at it. It's on the top of page 375. It's called Bayes' theorem. How y'all feel about that one?
Yeah, whatever.
Not that good, right? Pretty long, pretty ugly. Okay, fortunately we don't got to memorize this one. It's not on our green sheets and we don't have to memorize it. We're just going to do it. Okay, now I get really frustrated about this every year. You've got a Bayes' theorem problem on your next test. Guaranteed. You're going to have one of these. Okay, it's shocking to me every year the percentage of students that don't get it right. Here's what a Bayes' theorem problem is going to look like. Same question, probably not going to give you the first part, the first line, but I'm going to ask you a question like this. Given someone is a pro, you know they're a pro already, what was the probability that they went to college? Given someone's a pro, what were the chances they went to college? So let's write down, let's change those to symbols. So how would I write that? How would I write this part? Given that they're a pro, what's the probability they went to college? What's that? P given C. Everybody okay with that? Isn't that what I asked for? Given, no I didn't. No. What did I say?
They're called.
Okay, I said given they're a pro, what's the probability that they went to college? Yeah. Okay. Now notice we don't have that. That's not what we have. It's not information that was given. They're kind of giving it to you in a different order. Okay. So in this particular case, we've got what we're looking for. Now let's just go to our formulas and write down what that's going to be. So if it's the probability of college given pro, what do I write? What's on top?
C.
Probability of going to college and turning pro, and what's on the bottom?
P.
Probability of going pro. Okay, I just used our conditional probability. Now, anything up here look nice? Anything up here? No! Okay, I love that you said that. Let me. Can I just cancel these P's? In other words, here's what he's thinking. A lot of you are doing this. Oh yeah, the top, that's just probability of C times the probability of P. Over the bottom, that's the probability of P. I can just cancel. Can you do that? No, you can't just go right into that rule because you don't know that these two are independent or not. Okay, so don't fall into that trap. There's no canceling here. Does something else look nice? Something else should look nice to you.
Probability of going pro.
Didn't we already do this? Isn't that what we just did? Isn't that what we just found? By drawing our tree and finding all the ways you could possibly go pro? So we've got the bottom. The bottom is 0.000945. How about the top? Between college and pro? We have that too, don't we? Isn't that this route? Going college and going pro? Didn't we find out what that was? 0.00085. That Bayes' theorem formula that you have in your book, the bottom is that whole thing we did on our tree. The top is just multiplying your way down the tree. So if you can create this tree, I can ask you any kind of weird question like this. Okay? And you've already done the work. So when I ask you whatever this weird question is, write this formula, then you've got to go find these two things. But you should be able to see them from your tree. That's Bayes' theorem. Okay, yeah.
Can't you also just take 1 and subtract the probability of becoming pro without going to college?
Okay, say again now.
So, say we want to find the same thing, could you just
Okay, so given someone was a pro, so I know this person I got here is a pro, I'm trying to figure out, hey, what were the challenge, what was the possibility, what was the probability that you went to college? Okay, go on with what you're saying.
Oh, I know. No.
Right, see, this is the weird, when they switch that order, it messes everything up there. Okay. Okay, questions, comments? That's Bayes' theorem. It's the last kind of new thing we're learning this chapter.